This lesson is to go over lesson 20-2, which is more solving trig equations. And the assignment would be 4a and b, 5a and b. So you can omit c in that section. This lesson is a little different from the previous one because even though it's still with solving trig equations, what we're used to seeing is looking in our unit circle and being able to look at the special angles that it gives. Well, sometimes you may not get those special angles, so then you may not have is your solution as 30 degrees, 45 degrees, 6 degrees, and so on. There are going to be different ones. So this is going to require using a calculator, and I'm going to show both other ways of being able to use your calculator. So you can either go on Desmos and use desmos.com/scientific to use that. I'll show that way. And then I also have a feature here where you can, if you happen to have a graphing calculator on you as well, then you can use that too, okay? So let's go over a few steps, okay? So things to keep in mind when you're solving equations if you cannot use your unit circle. First, you would need to get the trig function by itself to solve. Find out in which quadrants does the solution lie, because if it's going to be positive or negative, you may have more than one solution depending on where that angle will be. And then you're going to calculate it, making sure whether you need to have it in degrees or radians. And after that, once you find out your solution, when you calculate it, then you need to use those reference angles from the quadrants to find all the solutions. Okay, so let's go over these examples over here. And I put those steps back over here in this page. Let's find the solutions of these two equations over the interval 0 to 360 degrees. So we are going to be having our answers to the nearest tenth of a degree. Okay, let's first do what we did last time with solving a trig equation with getting our trig function by itself. So in this case, I'm trying to get sine of theta by itself. So think of it like an algebraic equation. If we're trying to get that by itself, the first step we should do in here is to subtract 4 on both sides. So I have here 5 sine theta is equal to 3. And then I'm continue to get sine theta by itself, so I need to divide by 5 on both sides. So I should end up with sine of theta equals 3 over 5. Now 3 over 5 is not a usual value that we see in our unit circle, so it will be outside our unit circle, but we can calculate this from here. Before that, let's find out in which quadrants does that solution lie. Notice here that it says sine of theta is positive 3 over 5. Oops. Positive 3 over 5. With it being positive, let's think back to what we know with our unit circle. And let's remember that these are the quadrants, the way that they're labeled. And we said that all trig functions are positive here. And then we would use that mnemonic, all students take calculus. Okay, so then this is where sine is going to be positive, tangent is positive, cosine is positive in this quadrant. Okay, so the only quadrants where sine will be positive would be quadrant 1 and quadrant 2. In quadrant 3 and 4, sine is negative. So then we're going to note we'll be working with quadrant 1 and 2. Let's go ahead and calculate this now. So on the graphing calculator, I want to find out what theta is equal to. That's really what I'm trying to get to, but that means that the sign is in the way. So in order to get rid of that sign, I need to take the inverse sign of it. So this is the sine key, but I'm going to get that inverse sign that's over there by doing the second function. So now I have sine inverse of 3 over 5. So let me just note this again. In order to get theta, oops, let me use a different marker. in order to get theta by itself, I need to do sine inverse of 3 over 5 because I'm taking sine inverse on both sides here. Oh. So you need to take sine on this side too, okay? So that's what we're going to input in our calculator. Okay, before I click enter, let's make sure that I'm in the correct mode. So I go to mode over here, and it is already in degrees here. So you could just change it by going to those cursors, clicking enter, and then it's on degree, it's highlighted on degree. To quit, just click second function and then the mode key again to quit. And then when I click enter, I should get a value that's in degrees. So that's 36.9 degrees approximately. Let's put that there. 36.9 degrees. Okay, I am going to see how that looks like on Desmos, just to double check. So I need to go to function here, and there is inverse sine. I can put in 3 over 5, and it's in degrees over here. So then it is showing up 36.9 degrees. Okay. Now the last part here, we're not done yet. That's only one of your solutions. This one, 36.9 degrees, is over in the first quadrant. Now to find out my second quadrant, it's making 36.9 degrees in the second quadrant as a reference angle. So it's somewhere here. So it's either here in the first quadrant, being 36.9 degrees, or it is 36.9 degrees as a reference angle in the second quadrant. To find that, since its reference angle is off from the x, reference angle is always off of the x-axis, and this in the second quadrant, you're going to need to subtract 180 degrees here because this is 180 degrees in total. We're trying to find that whole, the entire angle measure here. So we'll subtract 180. Let me put a different marker. We'll subtract 180 minus 36.9 degrees. And let me just go ahead and use Desmos to calculate that. So 180 minus 36.9, and that would be 143.1. Okay, so I have theta is equal to 36.9 degrees and 143.1 degrees in there. Okay, so that would be our first problem here. And I'll just say theta equals this and this. Okay, I'm going to skip over this one for now, but let's take a look at another one of these for part C. This one, it says it's going, you want to find the solutions of that equation over 0 to 2 pi. That means that you want your answer in radians, and it's telling you to give the answer into the nearest thousand. So cosine squared of x. I'll put that over here. Cosine squared of x equals 1 over 16. I'm going to start with step 1 here. Let's get cosine by itself, okay? To get cosine by itself, there's a square in the way. That means I need to take the square root on both sides. When I take the square root on both sides, that means that you're going to have a positive and negative solution. Then I'm left with cosine of x equals positive, negative. Now for this square root here, since it's a square root of a fraction, it's the same thing if you do square root of the numerator over square root of the denominator. That means that I have positive, negative, square root of 1 is 1, and the square root of 16 is 4. So I'm left with cosine is positive and negative 1 over 4. So that's step 1. We got our trig function by itself. But now the quadrant, in which quadrant does the solution lie? I am going to go back to the unit circle. Now, since it has positive and negative 1/4, that means that it actually applies to all of these. So you will end up with 4 solutions here. Okay, now let's go to step 3. Let's use our calculator to find out what is our solution for this. And I need to do that by doing, so my step 3, I'm going to have to find x equals inverse cosine of 1/4, and also inverse cosine of negative 1/4. Okay, let's see here. So again, I'm going to need to make sure this is in radians. Quit. Then I'm going to do inverse cosine. Let me move this over a bit. Inverse cosine of 1/4. And I should get, I have 1.3, and it's going to be in thousands, 1.318 radians. So that's one of my solutions. Let me see if it's going to be a little different if I put in a negative 1/4. So let me enter that again, but instead I'm going to put negative, and make sure you're using that negative sign here. And I end up with 1.823. 1.823. Okay, now we're not used to seeing radians in this decimal form. Just keep in mind, we are going to be using, with pi, that's approximately 3.14. So you will need to subtract or add pi at some point in this to find the rest of the solutions, and it will come out as a decimal. Okay, you don't need to worry about putting them into fraction. So now let's find the rest of our solutions. We'll need to use our reference angles here. So in quadrant 1, finding out where exactly it is for 1.318 and 1.823, that's too much to figure out where exactly they are. There's no need to find that out in exact form. So all you need to just keep in mind is that you're either going to be adding or taking away 180 from it. In this case, pi. So you will subtract pi from 1.318, and you'll also be subtracting pi from 1.823. Okay, so if I were to do that, let's see here. To get pi here, and then let's make sure it's still in radians. Okay, pi is over here. I'm going to subtract 1.318. Notice here that this is giving us back the 1.823. Okay, and I'm going to show that other one, minus 1.823. Okay, so that was for the second quadrant in here, and that's giving us the same radian values. So what that's telling you is that these values here are already in the second quadrant. We need to find the rest of these. So to find the rest of these, I want you to, we're going to refer back to one part in this section. So a way of calculating the reference angle, a way of doing that is just by taking either, we did 180 minus that angle, or you could do pi minus that angle. We can also try pi plus that angle, and then also 2 pi plus that angle. Okay, so let's go ahead and do that. We'll calculate, and I'm going to take this away for now. So we already know we have those solutions, and then I'm going to do pi plus that. 1.38. I get 4.45, 4.460. So let's put that in there. Okay, that's one of those in radians. Let's take a pi plus 1.83. Excuse me, 1.823. That's going to be 4.965. And then let's try out the 2 pi minus those. So 2 pi minus 1.318. And it's going to give us those same values as before. Okay, so it looks like we are going to end up with these 4 solutions. Okay. So feel free to pause and see where you're at with solving these types of problems. I will go to the next part over here, but if you need to pause and take a break from it, feel free. I am going to continue on with the B and part D here. Okay, so remember that the goal for your assignment is to complete these 4 problems here and make sure you're solving these by using these steps. This is if you are not able to use your unit circle, because when you solved with getting your trig function by itself, you weren't able to use the same angles. Okay, so going over B and D, if you needed more examples, I'll go over those. So for cosine theta here, it has cotangent theta minus 2 equals -7. So I have cotangent minus 2 equals -7. I will get cotangent by itself by adding 2 on both sides. And I get cotangent equals -5. Now, the thing with this one is that this is a reciprocal function. And if you look in your calculator here, the only inverse functions that are given to you are for sine, cosine, and tangent. There's nothing with inverse cotangent, none of those. And you won't find it on any scientific calculator, actually. So to work with that, we know that cotangent is the reciprocal of tangent. So in this case, then, to find out what it is with tangent theta, we're just going to take the reciprocal of that value. So the reciprocal of -5 is -1/5. Then I can use my calculator to find out what that solution is. In which quadrants does this solution lie? Tangent is negative here. So that means that quadrant 1 will not work. Quadrant 3 will not work because tangent is positive in there. So that means it will have to be in quadrant 2 and quadrant 5. Okay, let's go ahead and use the calculator. I'm going to clear that. Let's take the inverse tangent of -1/5. And is that in radians? It is. I need it in degrees. So let's go back. Let's put that same thing. Now it's in degrees. So it is -11.3 approximately. Oh, this is in theta, in degrees. -11.3, or approximately that. Now, let's use our reference angles to find all the solutions. If I'm trying to find it for quadrant 2 and quadrant 4, that means I will have to, well, first, in -11.3, that's going to be in quadrant 4, since you're going in the negative direction. So we've already found where that will be for quadrant 4. for quadrant 2, we're going to need to find our negative 11.3. Now, it's a little weird to describe this because you're talking about a reference angle and you're seeing a negative value. You will have to ignore that negative for now. Just think of it as, where is 11.3 as a reference angle in quadrant 2? So this is where it is here. So then I am going to, in order to find out this angle here, I'm trying to find this. So that angle is by taking away 180 from there. And 180 minus 11.3, that's 168.7. Oops. 168.7 degrees. So we found both of those solutions. Oh, okay. So even though I found both of those, it does say I need to have it in the interval 0 to 360. So to find the other one, I'm going to take away 360 degrees, since it's going all the way around over here to get to that angle. I'm going to take away 360 degrees from that. 360 degrees minus 11.3. And again, you ignore that negative for now. You're really just trying to find out what it is at that reference angle. It's going to be 348.7 degrees. There's our final solution. Okay, so that was part B in that example. The last example, and if you feel comfortable about this already, then that's good. You can try out the assignment problems now. But if you want one last example, please continue on to this final one. Part D is asking to find the solution for 6 cosecant plus 9 equals 0. Okay. So I'm hoping that by now you could do the rest of these steps on your own and then just use my work as just a way of checking if you're on the right track. So I'll just go ahead and move forward. This one is, I'm subtracting 9 on both sides. I have 6 cosecant x equals negative 9. I have to divide by 6 on both sides. I have cosecant of x equals, let's simplify the fraction. It can be simplified to negative 3 over 2. Cosecant is a reciprocal function. It's the reciprocal of sine. And that means that if cosecant equals negative 3 over 2, that means sine of x is negative 2 over 3. What quadrant would that solution belong? It's a negative in there. So then that means that it's not going to be here or here. It's going to be in quadrants 3 and 4. So then if it's in quadrants 3 and 4, let's note that. Keep that in mind when we're going to put that in our calculator. Let's do it in the Desmos one this time. I said over here it's negative 2 over 3. Okay. So inverse sine of negative 2 over 3. This is in degrees. So to put it in radians, it's negative 0.730. Okay. Where exactly is that in your quadrants? You want that to be for quadrant 3 and quadrant 4. For quadrant 3, you're going to have to add pi to this positive 0.73. So let's find out what that is. Pi plus 0.730. That's going to be approximately, and keep in mind this is for quadrant 3. It's in radians. Okay, that's 3.872. For quadrant 4, we're going to have to subtract 2 pi from 0.73. That's going to end up, oh, let me just go back to decimals here. So 2 pi minus 0.73. That's 5.553. Okay, so your solutions are 3.872 and 5.553. Okay, so you went through several examples. I know that this was a fairly long lesson video, but feel free to continue looking through these examples. Feel free to ask me questions, and then make sure that you are showing all of your work for these assignments.